They just missed a bunch. That's okay. All right, so simplify that for me. Well, first of all, can I put negative 2i and 15i together? That's 13i, right? And minus 3i squared would be negative 3 times negative 1, wouldn't it? All right, so I have 10 plus 13i plus 3. So that would be 13 plus 13i. Alrighty, questions on that so far? Alright, so that's how we add, subtract complex numbers. In a second we're going to talk about how we divide them. So it is not proper, just like in fractions, it's not proper to have a square root on the bottom. I don't know if you knew that. It is not proper to have an I on the bottom of a fraction. So we use something called complex conjugates to get rid of I on the bottom of the fraction, and I'll show you how that works. The complex conjugate of an imaginary number is just to take its opposite. So the complex conjugate of a plus bi is just a minus bi. So the only thing that changed here was what? This became a negative. What that allows us to do is when we multiply it out, it's going to make the i's cancel when we change the sign in between the real and imaginary part. So I'm going to show you first for this one, 4i is the same as this, 0 plus 4i, because it doesn't have a real part, it has an imaginary part. So what would the complex conjugate of that be then, do you think? 0 minus 4i, which is the same thing as just negative 4i. Alright, so the complex conjugate of 4i is negative 4i. So we're going to use the complex conjugate to write this in standard form. The only issue here is you may have an I on the top, you may not have it on the bottom. So what am I trying to get rid of then? What do you see on the bottom? 2 minus 3i. So what we are going to do is we are going to multiply, so you know what I'm doing, the top and bottom by the complex conjugate of 2 minus 3i. What is the complex conjugate of 2 minus 3i? 2 plus 3i. Okay. Let's do it. So this is my fraction. I'm going to put this in parentheses, multiply top and bottom by 2 plus 3i. And you're going to see in a second, once I multiply that out, it will remove the I in the bottom. Okay, so first let's do the top. I have 10 plus 15i plus 2i. I'm going to put those together. That makes 17i. Plus 3i squared. I'll simplify that in a second. I hope you guys can see in a second why the complex conjugate will work. Hey Nick, if I see it again, I'm going to take it. Alright, 2 times 2 is 4. What happens when I do this? I have 6i, and what do I have there? Negative 6i. Now the reason why that works is because one is the positive and one is the negative. This is why taking the complex conjugate is the only thing that will do this. What's going to happen if I have 6i and negative 6i and I put them together? They cancel, and then I've gotten rid of the i's. Well, you might say, what about the last one? Negative 3i times 3i is negative 9i squared, isn't it? And can't I take out that I squared and replace it with a negative 1? Yeah, okay, so let's simplify now. I like to write a lot of in-between steps. How come I made that a -3? Because I multiplied 3 times -1, I squared from above equals -1. And this I'm going to write 4 minus a -9, so I'm going to write 4 plus 9. Okay, finally, let's simplify. 10 minus 3 is 7. 7 plus 17i over 13. You may leave it like that, or you can separate it as 7 over 13 plus 17 over 13i. Either or is fine. How we doing? Do you recognize this from last year? No. Okay. Well, good, it's you then. You've heard about imaginary numbers, maybe, but you maybe did, or imaginary solutions, but you maybe didn't find them. All right, so let's talk about complex numbers in quadratics. First of all, I'm going to write this little diagram for you. At the top, I'm going to put complex numbers. So you understand, complex numbers, it describes every single number that we would ever talk about in math. But then we separate in between real, which is up to this point probably all you've talked about, real numbers, and non-real, which we would say are imaginary, okay? Non-real are going to have i's in them. Real, we have all kinds of real numbers. We have rational numbers, like anything that can be written as a fraction. We have irrational numbers, like pi or the square root of 5. Just so you're clear, the complex numbers describes all of them. We're focusing on non-reals today, but it's the combination of the two when I talk about those things. Okay, quadratics. So, when you have a quadratic, we have this thing called the discriminant. You guys recognize it because that's underneath the square root symbol in the quadratic formula, right? And so far, if I've said it's a negative number, you've told me there's no solution, because we can't take the square root of a negative number, right? So I'm going to point out to you, if it's positive, you would get 2 solutions, and the graph would look like this. How many times does it touch the x-axis? 2, okay? If it equals 0, there is one solution, and what that means is the parabola would be resting right on, or have a vertex on the x-axis. So it's got one solution. And if the discriminant, or b squared minus 4ac, is negative, there are not real solutions. So what it looks like on the graph is this. It doesn't touch the x-axis. There are no real answers to that. You couldn't find them on your calculator. However, there are 2 imaginary solutions, and they are a complex conjugate pair. All right, so somebody, if you have your graphing calculator handy, can you pull up x squared plus x plus 1, please, on your graphing calculator? Same thing. If I figure that out again, I'm going to take it. Put it away. All right. I'm hoping you see what I see. Is that what you see? Does it touch the x-axis? No. Okay. Because it's degree 2, it does have two complex solutions. They could be a combination of real and imaginary. What this tells me is they are both imaginary because it doesn't ever touch the x-axis. Here's how we find them. Quadratic formula. A, B, and C are all 1. So here we go. Negative B would be -1 plus or minus square root. B squared would be 1 squared minus 4 times A times C all over 2A. Alright, so I do this. What's 1 squared minus 4? -3, correct? So I have -1 plus or minus the square root of -3 over 2. Now, the way that I write that, this is not real. The way that I'm going to write that is I am going to make this a root 3i. I can take out the square root of -1, can't I? These would be my two solutions. Okay. How we doing? Alright, the last thing that we're going to talk about today, we'll save absolute value and distance and midpoint for tomorrow, is the complex plane. So there's a way of graphing imaginary numbers, and it looks kind of like an y-axis, but we call this the real and this the imaginary. So if I graph the point, I don't know, -1 plus 2i, what's the real part of this expression? -1, so I'd go -1 over here, and the imaginary part is 2, right? So I'd go up 2. That would be the point -1 plus 2i on the complex plane. Okay. Would you guys take out your book and open to section 2.5, please?